Gel caps are a scam. I'm a licensed pharmacist in 3 states, and gel caps do not work any quicker than tablets. I recently did an experiment where I filmed myself dissolving the tablet and gel cap in water, and to everyone's dismay, the tablet actually dissolved quicker. Folks were very quick to point out that water is not stomach acid. Well, I made a second video where I dissolved it in stomach acid-like substance, and still the tablet dissolved quicker. Because I'm an expert and a trained professional, I knew that the thing that was important is actually temperature is actually more important than anything, and water content. That's what causes the tablet to swell and release the active pharmaceutical ingredient, or in the case of the gel cap, break down and release the liquid containing the active pharmaceutical ingredient. Acidity, or pH, does not matter for dissolution. Dissolution is different from solubility. People have this erroneous perception that an acid is something that just kind of eats away things and it's dangerous, and if you have a gel cap, it'll dissolve really quickly in an acid solution. Okay, that's not true. There's a couple acids that do something similar, but they're few and far between, and it's certainly not stomach acid. The definition of an acid is a hydrogen donor, or a proton donor, that once dissolved in an aqueous medium gives that hydrogen atom to another molecule if one is available. It has nothing to do with the corrosive nature that everyone thinks it does. This is so obvious to me as a trained professional that if somebody was trying to prove to me that a tablet or a capsule dissolved quicker or slower than the other, and they used a preparation containing hydrochloric acid or a similar acid, I would know immediately that they have no idea what they're talking about. Now, after the active pharmaceutical ingredient is released, after the tablet breaks down, or after the capsule releases its contents, then pH really matters. Then acidity is crucial. There is millions of dollars a year spent on making sure these molecules will be protonated in the stomach. But before we even get to that step, first we have to break down the tablet, which, as we've seen now twice, the tablet dissolves quicker than the gel cap. Solubility is measured at the molecular level, so each individual molecule will interact with the water and disperse somewhat evenly, and particularly if it is protonated or not, depending on the structure of the molecule. None of this really matters anyway, because a tablet or a capsule is going to be dissolved and it's going to release its active pharmaceutical ingredient before it gets to the intestines anyway, and that's where meds are actually absorbed, at least for the most part. One very overstimulated little fella mentioned enzymes and how they may play a role in the dissolution of a tablet or a capsule, particularly a gel cap. And although that's a cute thought, I added it just to prove a point. It really doesn't matter in the short term. Over a long period of time, yeah, it probably would degrade the gel cap. I'm talking like half hour, maybe even a couple hours. But at that point, it's irrelevant because it would be well into your gut and well into your intestines anyway. Furthermore, there are actual reasons why we would want to take a pill to go through the stomach unchanged and then release its contents in the intestine. And there are really genius mechanisms to allow this to happen. Absolutely zero of them have anything to do with enzyme degradation. This is so irrelevant, the United States Pharmacopoeia actually doesn't even recommend using enzymes for dissolution testing. However, they do recognize that it may be important for a gel cap, but as I stated earlier, this is over a long period of time. It's not going to matter for what we're talking about here today. Another very overstimulated little fella mentioned that pharmacists are not the be-all end-all for something like this, and that is unequivocally false. Pharmacists are the only profession that learn about this. This study of science is called pharmaceutics. Doctors do not learn about it. Medicinal chemists do not learn about it. That last point I would know specifically because while I was getting my doctorate of pharmacy, I took graduate level medicinal chemistry courses with the PhD students. So not only are pharmacists the experts in dissolution, we are the only profession that learns it. The United States Pharmacopoeia recommends about a pH of 1.2 to simulate gastric fluid, and my second video was a little bit higher than that. It was somewhere between 1 and 2. You couldn't really quite tell with the pH test strip, but regardless, that difference is not going to matter in this particular dissolution test. What I thought, and I think what people initially thought when I was dissolving these in water, was it was a test to prove that gel caps are a scam, but really it ended up being an experiment to prove how attached people can get to their preconceived notions. You could literally have an expert tell you and show you that something is a scam, but if you want to believe it's not, you will find X, Y, and Z reason why your reality is different than actual reality. I see this all the time with things like phenylephrine. I'll tell people this is junk, don't buy it, buy this instead. And they're like, no, it's the only thing that works for me. Same thing with guaifenesin. So gel caps are a scam. Whether you want to believe it or not, I don't think anyone really cares.